Hello YouTube and preppers, this is the Comms Prepper with a video about privacy tones and more specifically how they work in our radios. Many of us have FRS, GMRS, amateur radios, and business band radios that have these tones that are a programmable option in our software or through our keypads. In the industry, these are referred to as continuous tone coded squelch system CTCSS tones. Motorola's proprietary term is private line or PL. General Electric, when they were producing radios, called theirs Channel Guard or CG, and there's a digital version called Digital Coded Squelch System or DCS. One of the bottom lines up front from this video is privacy tones provide absolutely no privacy. They provide no level of scrambling or encryption or security. They're merely used as a filtering tool for the listening station to only receive traffic from other radios that have the same tone programmed into it. So if you have 15 people with radios on the same frequency, but only 2 of you have matching tones, then only the 2 of you will be able to hear each other. Any radio on the same frequency that's not using any tone system will hear every transmission you make. So that's one of the bottom lines up front. Privacy tones are not private. Here are the tones we're familiar with that we'll see in the back of our radio manuals. Typically, they start at 67 Hertz or 67 cycles per second and go as high as 254 Hertz or 254 cycles per second. And these are referred to as subaudible tones, or tones that can't be heard with the human ear. And you'll notice with the first tone, it's only 7 Hertz above the frequency of the power out of your wall outlet, which is 60 cycles a second. So these are subaudible tones. And you can't hear them with your ear unless maybe at 254, if you have a really good set of ears, you might hear a slight hum. So before I go into the tones, I'm going to go into an FM radio block diagram so you can get an idea of the mechanics that are taking place. You have an antenna represented by the schematic symbol, the triangle, to an RF amplifier, a mixer with a local oscillator, an intermediate frequency amplifier, a detector where the squelch level is set, an audio amplifier where the volume level is set, and in the speaker you get to hear the transmission. So how this starts is you receive a radio transmission, and I highlighted that in yellow, and there's a blue sine wave there, and that's a modulated signal coming in because you can see how the peaks vary in distances between each other. And then down below, the green sine wave is your operating frequency, what you programmed into your radio for that channel, or what you entered into the keypad. That's the frequency the local oscillator is producing, and that gets passed up to the mixer. And in the mixer, all mixers, when you put 2 frequencies together, you get the sum of those frequencies, the differences, and the originals. So you have 4 outputs for an input. And again, as you can see with the red arrows, is the deviation between the peaks of the received signal, and then on the local oscillator, there's no deviation. And when this comes into the mixer, it creates an intermediate frequency that still retains that deviation in frequency. And in that deviation lies the voice of the transmitting station. And that's what we want to recover at the speaker. That intermediate frequency gets over to the detector. In this example, the detector serving 2 functions. It's setting the squelch threshold level, how much signal you want to have come into the detector before it'll turn on and pass audio to the audio amplifier to the speaker, and to extract the original voice from the transmission to pass to the speaker. So that's the function of the detector, to recover the original voice transmission and control the squelch level before it gets passed to the audio amplifier. And again, this is a simplified version. Again, you adjust your volume knob, and that adjusts the level of audio you hear at the speaker. So how does this come together? So in the top example here, I have a traditional FM transmission. You have your operating frequency unmodulated. The peaks are even. I modulate that or deviate that with my voice through a microphone, and that creates deviations or changes in the frequency. It changes in the peaks, and that's what gets sent out over the antenna, and that's what the receiving radio is looking for, those changes in the frequency deviations, so it can recover that and recreate that spoken word, that audio at the received speaker. For PL, looking at the bottom example, again you have your operating frequency, your channel, then we add your voice into it, but also we add one of the subaudible tones. And below that's a picture of an aftermarket encoder board for older radios. Didn't come with this feature from the factory. So your voice and the tone are inserted into the operating frequency, creating a new transmitted frequency where the deviations between the peaks contain your voice and the subaudible tone. And that subaudible tone is what the receiving radio is going to be looking for, in addition to the voice. So back to the block diagram. Again, we have the modulated signal coming in on the antenna with the deviation in the peaks, the reference oscillator or local oscillator coming up to the mixer, which creates the intermediate frequency, which retain the deviations from the original frequency, and embedded in those frequency deviations between those peaks above the IF amplifier is the sending station's voice and the subaudible tone that they inserted into that transmission. So now the detector has three functions in this picture. The first function is, of course, to recover the voice from the original frequency coming in and look for that embedded tone within that frequency as well, and the squelch level setting. And I represented this by a little switch after the detector. And if the detector gets a signal in where the squelch level is where you want it, and that tone is present, then that switch will close and it will pass the audio or the voice to the audio amplifier so you can hear it out of your speaker by adjusting your volume knob. And that's how this filtering takes place. So this configuration here, this block diagram, that detector will only pass audio to the speaker that has the matching tone in there. Any frequency or signal coming in that has no tone or an improper tone, that switch will never be closed and you'll never hear that transmission. But for radios that aren't using PL or using these tones, the switch is always on, so they're getting everything. So again, this is how this works as a filter, not providing any kind of security or encryption. There's nothing private about this. And this is how this tone controls what you hear. And the idea behind it is you can have a lot of users on one frequency and filter out the other users by just setting up your own group to say, I only want to hear radios that are using this tone, and dismiss all the other ones. So I hope this helps explain how privacy tones work. And as always, thank you for watching, and thank you for subscribing to my channel. This has been the Comms Prepper.